Hi, Dave Snyder here. It is the 17th day of March 2014, and I just noticed this pattern here. I mean, I didn't just notice it. I've been here before, but see the circular pattern here? Okay, and you see this shape, this cloud shape right here. See the shape of this cloud? To me, that looks like Greenland. Like Greenland used to be right. This part of Greenland used to be right here with Iceland. Iceland, like in this position. I don't know if you've seen the video where I showed Greenland. This is a Schrodinger for sure, because if you look at like Google Earth and you go up to Greenland, you used to see it in the weather all the time on Google Earth. You used to see right here in the weather this circular pattern in the clouds, but they don't show it on Google Earth much anymore, hardly ever. I mean, but you used to see it really clear right here, this circular shape right there at the curve of Greenland, right here, right? And it never used to be right over Iceland. It was usually right in here, in this area. You can kind of see it right, I guess right here a little bit. Right here. Right? Okay, and I showed before that if you take Greenland and overlay it somewhere besides the pole, because you have to take it somewhere else. You can't do it at the pole. You can't overlay pictures up here. Cannot do it. It makes the pictures too small, so you can't. It squeezes the picture down. So you have to take this image of Greenland like this, save it like this, save it, just save the image, and then once you save the image, you can just move it and overlay it down here on the equator where it doesn't squeeze the picture. So that's what you do when you have to do anything at the poles. If you want to do anything over Antarctica or the Arctic Circle or whatever, you have to save it and bring it to the Pacific or whatever. I use the Pacific because it's just a clean canvas area where I can use this area to put stuff onto. So anyways, I already have that picture saved of Greenland, and I'm just going to bring it up here. Greenland. We're just going to go over a few of the things I've gone over already, but some people haven't seen those things, so I'm just going to go ahead and do it now. Okay, so here's Greenland, and I'm just going to leave it big, a little bit bigger than it is actually in reality, I guess, not much bigger. Try to get it right down here where it's centered. Okay, something like that. Try to get it shaped properly. It might be one like that. I don't know. It doesn't matter. Get that right there. And I showed before, if you take the lunar South Pole and Schrodinger, reverse it, as I showed you before. Schrodinger, right here. Okay, that's the one I use. There we go. Okay, use this picture. And what you want to do with this picture is you want to get Schrodinger right up here where I was saying it was, and then you just take this, turn it to where you're going to see it. Right, you're going to see it pretty quickly. You got to get Schrodinger right up here, and it's probably not big enough yet. Let me see. I might have to shrink down. Then you see this corner of this lunar South Pole. You want to line that up right there, right there. See that? See that corner right there, right here? You want to put that right there. That is absolutely from this. You can see the shape of Greenland. It's probably too small still, I think. A little bit too small. It's hard to get this picture big because I might have to shrink down Greenland actually to make this work right. And it might be Iceland. This might be Iceland. You know what I mean? Because it does fall right into there. You can get it to fall right in the center, and it's the right size. It ends up being the right size, as you can see. You get that corner lined up right here. Just a little off right there. That's the same thing right there. You see the shape of Greenland in the lunar South Pole. See the curve here, it comes out to the point. And there's ways to confirm it. You can confirm this pretty easily, as a matter of fact. See this big crater? That probably goes over that island right there. Look, there's that island right there. See that? You probably want to get that over that island. Like this. Just about right there. And then look at it. Oh, look at that. See? There it is. Perfectly. So Greenland, or Iceland, does not always fall into that area. It's off to the side. And this is where I'd never seen the cloud pattern really over Iceland. It was always like right here at the curve. right where you see it right here. Okay, get that there, and look at, you can see Greenland, and you got to understand that this is a shitty image of the moon. That's what they give you on Google Earth. That's what NASA gives you. Period. They give you crap, total crap. And I know I've showed this hitting other places on the Earth, but you know, it's hit more than once. Obviously, you can believe what you want, but just get it lined up. The weather will show this up here at times when you get the weather. See, I can't take the weather and bring it down there. Well, I could, I guess. I could save it with the weather on, but the weather's always crappy at the North Pole anyway, especially on Google Earth. And they don't show it to you on Wonder Maps. I wonder why. And I'm telling you, if they showed the lunar, or showed the South Pole, Antarctica, and the North Pole on Wonder Maps, we would all know that the moon has hit the Earth many times. It would be so clear to everybody that it would be undeniable. Because those two areas, when I used to use Google Earth and show the weather here when it was good, still good, man, I'm telling you, that is one large impact down there. But that is Greenland right there. That I can guarantee, because I've seen this weather pattern right here, Schrodinger's weather pattern right there, and the print would be perfect. It's usually perfect. It used to be. This might not be the right time of year. It's pretty seasonal. The weather, you know, pretty seasonal, as we're all aware of. But you get that island right there lined up in that crater there, and you'll be all right. Puts everything right in place perfectly. See that? That's Greenland, people. Okay, so that's one. I wanted to point that out to somebody because the other day they were talking about Mare Oriental fitting here. And it might fit there too. It probably does fit there. But this is a Schrodinger print that circulates right in this area. As you can see, but anyways, so now that you know Schrodinger goes there, okay, and we know Schrodinger goes down here, right? So you bring the two together. You bring Greenland and you put it together with Africa the way that, okay, now it's a little different the way that Schrodinger fits when you do it this way, and it's probably because, well, hell, I don't know why it is, but you put Greenland here now like this. Here, I'm just going to move that picture I already put up over here, over there, since I'm having a bunch of them around. Okay, so what you want to do is you want to take this picture, and now you want, well, actually you want to go like this first. You want to take the other picture first, this picture, and you take it over to Africa, where you know it hit in Africa off to this, but it's a little different alignment when you put it over here for this for what I'm going to show you to confirm. Okay, so here you go. You want to get this. You want to get Schrodinger right here, right below Lake Victoria. See the bulge? See this bulge right here? It lines up pretty much right here in this spot. You put it right there, kind of like that, right? Then you got to turn it to get this part over here, like this. And then you'll start to see it. You'll start to see. You get this turned and you get this down right where I just said, right there where that bulge is right there, pretty much. And then you adjust this part. See this part right here? This is what hits this area in the ocean right there. See this volcanic area, these seamounts, whatever? That's right there. That's the certainty right there. See that? Look at that. Watch. I'll get it right there. I'll get it right in position there. That's a certainty right there, because we know Schrodinger hits over here, and we know we can see that aligns right there. Now we bring Greenland over here, and we see how Greenland fits with this. The way we had Greenland over, you know what I'm saying. This is how I confirm stuff. Anyways, you start to put all the Schrodingers together, because obviously it couldn't be that many impacts of Schrodinger. It's got to be pretty much one impact, or maybe two or something that have spread around. What, you know, it hit when it was the supercontinent or something, and everything has been moved since then. Is what because I believe the continents were built and created in layers myself. The moon was hitting one area of the Earth at a time, and creating a layer, on top of a layer, maybe not directly on top, but off to the side or whatever. And then when the moon would hit, it eventually broke them all up and moved things around. And that's my belief, because just like I said, the land down under and all that stuff. Okay, so you get this up here. You take this this one away. Actually, get that lined up. And just take this one away. We'll just work with this one now. So now we know Greenland, how Greenland fit with the Schrodinger. So now we just look at it right here, and you can see, look, you start to see this shape again right here, this V, and it's almost in line with that. You just got to do a little fudging to get that right in place. You can see once you get that right up there, it fits really well along that little, volcanic area of the ocean. See that? Okay, and then when you look at the tip, which this, I don't have this very long. It's kind of needs to be a little bit longer, I think. Like that. It's probably too big still. I'm going to shrink it down, get it to the right size now. Now it matters if it's to scale. Before, I was just trying to show you something. Okay, now you look right here by Africa, and you can see the tip of Greenland where it comes in right here. Watch. See that? Perfect. And then you see right here, look at this. This was there was a volcano right there. You can see it fit right. It would go right around Victoria right there. See that? If you were to move it just over a little bit, it'd go right here, like next to Lake Victoria. Look at that. It's the perfect size and everything. See that? Right there. And then look at the tip of Greenland right there. It comes right up here and fits perfect. You'll find other things that'll confirm, I'm sure. You get that like that, and you come back over here. This will be a little bit off now. But things were moving. You see, you got to figure things were moving, but it's still parallel with that ocean floor shape. See that? It's still parallel with that, and I may not have it big enough either. But you can see. And then you got the straight line at Madagascar right here, and then you got a straight line right here. See that right there? That all falls into place. That's how you confirm. That's how I confirm. That straight line has to go, like right along Madagascar. And I'll bet you I bet you if you were to match the rocks in Madagascar to the rocks here, this part of Greenland or wherever this area is right here, and look at the North Magnetic Pole right there. I mean, that probably has nothing to do with this part, but see, now this end's a little bit off, but like I said, things move around. But if you're that close to everything falling into place like that, you know that you're onto something there. You know what I mean? You got the tip. Look at the tip. You see it fit right there. And then you see that little curve right there at Victoria. You got the straight edge that matches Madagascar. You got the ocean floor that matches this V right here. And it just takes a lot of looking at the Earth and moving the continents around. You have to move the continents around because they were not always where they are today. They were created together in one area when the moon was hitting the supercontinent, I believe. And it's all over the place. I mean, it's really. You have to put things on top of each other. You have to turn things upside down. You'll see also in the weather at times, like this weather, like the tip of South America right here, this area here. If you turn the weather on, I don't know, you'll see this shape in the weather, like up here, going this direction. This straight. You'll see the tip of South America right up here at times. Not now, but I've seen it before. I mean, I got the overlays up here somewhere, and I probably saved the image of the weather, but I'm so unorganized I don't know where it is. But you will see things like that. You have to watch the weather shapes. Like I said, I've seen Australia's weather shape, the outline of Australia in the weather, in the clouds right here before, right up in this area. I was able to bring Australia right up there, and it fit absolutely perfect in the weather. So it was either there at one time, Australia was, but I think Australia is in the same place it's always been. I think this has moved. I think this is being the same shape as Australia. It was this area that moved since it was so close to this area, because these are the same shape, right? Like I said, the weather from down here will fit up here, and the weather from up here will fit down here absolutely perfect all the time. So it gets a little confusing. It seems like everything happens right here, to be honest. It seems to me that everything happens in the Pacific right here, where you see all of the subduction and the big scars of impacts. These are from impacts, subduction or not. It's subducting now, but I mean it's started by an impact. Okay. So you have to put you can put like India will go somewhere around this. I mean, it all starts over here. Like I said, South America could go right here, or Africa goes right here. It all fits over here. So that was one way I confirm things, is by putting putting the same impact. If I find Schrodinger in 2 different places or 3 different places, I'll put all 3 of those places together and find out how they go together. And now I've forgotten most of the things that I've done in the past. This way, just the way I am. I'm not really into documenting this too much, but because I already know that the moon's hit the Earth. I already know it. I've put the Earth together so many times in the past and seen so many things. I already know. So it's not important to me to try to prove it to you or anybody. I mean, I'm just trying to document what I find so that I can say someday, look, I told you. That's the only reason I do it, really, and just to share it, to share it with people so they can check it out too. Maybe they'll figure it out and get it all documented and squared away perfectly. I'm not going to be able to do that, I'm sure, ever. Besides, that would be boring. I would not have nothing to do anymore. This is like my video game, where you learn something while you play. I don't like wasting my time on other video games where you don't learn anything. So, anyways, that's the way I confirm things. You just have to move a lot of things around. I mean, there's areas that are really interesting. Like you look at the shape of the ocean floor right here. See the shape of this ocean floor? See how it's got this curve right here? This really interesting curve. And then you got this curve right here, but it won't fit that way. I've actually taken this area right here and flipped it upside down. The Himalayas and the Tibetan Plateau, this whole area, and flipped it upside down, and it will fit so nicely right here, upside down, and the other way. And then when you turn the weather on, the weather would always fit it. But people thought I was crazy for doing that. But you got to figure, if this is a big slab of rock, right, and it's on the Earth, and this volcano or whatever volcano, that's on the ocean floor created it, because there is a mother volcano on the Earth, people, and this is from the same volcano. And so is this area, so is this area, and so are this. These were all built by the same hot spot on the Earth. This, I guarantee it. You can put, so you want to take like Yellowstone, and this was a volcanic opening right here at one time. This desert. It's a huge volcano at one time, and you'll see it in Australia. You'll see the shape of it down here in Australia, and you'll see it. It goes together. There's like one mother hot spot. Like it could be the Azores. It could be. There's a lot of places where it could be. This right here. So when you turn this upside down, this being a big bunch of, mostly rock, this whole area being solid rock almost, if the moon were to hit right here, which, or up here, you don't think that it could flip over a big layer of rock if the moon hit the Earth? I think it could. I would never put it out of my mind anyway. I wouldn't close it off to not be, and say it wouldn't be possible, because anything's possible. And people always try to tell me that, if the moon hit the Earth, if this would happen. You don't know that. How the hell do you know what would happen? Nobody knows. Well, maybe there are some scientists that know, that have really racked their brains on this and have that are just obsessed with it. But I'm not really obsessed with it. It interests me, and I look at it every day, but I'm not obsessed with it. It's not like an obsession. I already understand that the moon's hit the Earth. I know that. I've seen all I need to know. All I need to see, I've seen it already. To know that it can't be a hoax that they could pull off that easily. And I've seen things other people have done, and it's not a hoax. You see that they give you enough. You can see from what they give you what's going on. And if you can't see it, you're really not looking. You know what I'm saying? You're not looking, because these are impacts. This is all impact area here, all of it. All of its, every continent is a result of an impact. The volcanic eruption afterwards or something they're all results of impacts, every one of them. The oceans and everything. So, I mean, and then you go to the moon. You look at the moon like I've showed before. You go to the moon, and you got to look at these craters properly. This right here is an impact. It's not just this big. It's this big. It's all the way around, but it's been covered or something by these most recent impacts, I think. That's my belief. This is the center of an impact, and this is the whole impact. These are centers, or off to the side sometimes. But like this is one giant impact, but it goes around the outside too. But that's the main part of the impact right there. Okay, that's the Canadian Shield. This is the Canadian Shield right here. I think that's why they call it the shield, as a matter of fact, because it looks like a shield almost. But that's the Canadian shield. You put that with the Canadian shield, and you got, this is like this is down by the Great Lakes or off the east coast of North America. This is Europe and Central Asia, or or like I don't know, not really Central Asia, but yeah, part of it. And Europe being right over here. This is one big impact, but it's not just this. It goes all the way around. It's just been covered by these impacts. This is what faces the Earth now. This is what shapes the Earth lately. You know, the most recent impacts is this side of the moon, the dark side. This is the dark side of the moon. This is not, obviously. This is the dark side, the side that hits us. It's magnetically stuck to facing us. Why do you think that is? Because it's magnetically attracted to, and locked in that orbit, facing us that way, because it's got to be magnetic. It's the only thing it can be. Only thing it can be that does that. The only reason why it can face the Earth the same way all the time is magnetism. And there's no other way you can explain it any other way, and you won't convince me it's magnetism. There's no other thing that can do that. It has to be magnetism that keeps it facing the Earth the same way all the time. So there's an attraction, obviously, and it's not the sun that keeps it facing the same way all the time. Well, actually, I shouldn't say that. It could be part of the sun doing that, but it's mostly between the Earth and the moon, because we know that force is there with the tides. All right, it shapes our weather. It pulls the tides. It pulls the Earth. It's absolutely got an attraction, magnetic attraction, not gravitational. The gravitational thing with the tides or whatever, maybe, I don't know, but the magnetism thing is there. You cannot deny that. It's absolutely there. This is the side that's hit us most times in the recent, past, it seems like. So it's no wonder why it faces us, and no wonder. It's magnetism. These are big impacts, big. The whole side, just like this side, the whole side. Not just this, but this, the whole thing. You can see it. It's been covered some. Like this is the biggest impact of all. Look at this in color. That's the deepest impact of them all. The Aitken Basin. Look at that. Look at this. 9 kilometers deep. The darkest blue. This is 7. And you can see that this is the highest. Higher areas. Well, it's obviously this has been built up from debris that rains down or something. Then you got this. This is the most recent side that hits us. That's my belief. There's the Imbrium right there. So that's how I look at things on the Earth and the Moon. Because I've seen all this stuff clearly in the weather before. All of it. All of this shit. Every bit of it. All of it. This here, all of this. Especially this side of the Moon. But the South Pole too, every day, South Pole, every day. Somewhere. And then you got this one here, Mare Austral. You can look at the way that one, it's a totally different type of impact. But you can look up in the Sahara, and remember when I showed the other day that V and that little shape that looks like it comes to a point in the Sahara? This is the Humboldt crater, and you put this right over the Sahara Desert. And you put that in the same place I showed you to put that other one the other day. I'll show you right now. I'm not going to do the overlay, but I'll show you what I'm talking about. You just got to get familiar with the shapes. Look at this. See this point? Put Mare Austral right here. Make sure you reverse it. Put that point right here. Humboldt crater fits right here. I mean, you can see there's a big circular shape right there where they don't show you anything but, sand or whatever. But there's something there. And if they showed you what was there, it would be a circular crater print from the Humboldt crater. I'm sure of it. And then you see but you see this area is circular. And I just showed you what Mare Austral looks like. So that's what I do. I just take and move things around and then the weather, I use weather to confirm. I used to not use the weather. I had all these already in place, and then when I realized the weather showed things, I just brought up the weather with the ones I already had in place, and it would just show different things sometimes, or sometimes it would show exactly what I already had. So that's what you do. Then you realize like Sailor Moon has the story with the moon and the earth battling it out. Everything ties it together. The Bible, if you just make sense of the Bible, if you think about this as you're reading the Bible, I'm sure this will. And then you got the crescent moon and things on the flags and Allah supposedly being the moon god or whatever. I'm not saying that it's true because I don't know. I'm just saying that's what people are saying. You look it up and then just a lot of things tied together. And then you just look at the things around you with your own two eyes. You go out to the mountains like Yosemite. I've been there a few times. And you see the rocks and you see the big boulders and you just know. Things like that. Big mountains with big boulders and things like that. And you look at that and it's just incredible. You have to know. Things are bigger than they look. Just look at the big picture. It's a big planet. Something big shaped all this. We're not seeing it. Nothing but little volcanoes and earthquakes. I mean, those are big, but they don't change things that much. Maybe I know over billions of years. I know. Over billions of years, the moon's hit the Earth many times. So check it out. I mean, either that or they're trying super duper hard to make it look that way. And I couldn't understand any reason why they would do that except for, they wouldn't make it look like that. I mean, they don't want you to know. They're trying hard not to make it so you can't see it by hiding the weather and shapes on the earth and the ocean floor. So, anyways, that's what you just gotta. Don't be so sure of the first thing that you find when you see something fit. Don't be so sure of it. Don't, because you might find that it's a whole different area of the moon. You can be sure that it's something, but when you try the first thing, and just remember that there's all kinds of most of the moon craters are basically the same shape once you get down to it. All right, have a good day.